So summer came, it was way too hot to be out in the garage. Winter came, said we're gonna just skip right over fall, and it's got really super cold. So I moved everything inside to the basement to work on something inside. I'm getting ready to do the engine, but I need an engine run stand. These things run super expensive, in the couple of $1,000s range. So I'm gonna make one on the cheap. I found a cheap, just regular stand for the engine to sit on, and I'm going to use some metal bits that I'm going to cut and drill holes in because I can't really weld in my basement. I mean, I can, but I'm not going to because I don't want to weld in my basement. I'll just wait till I can go back outside to weld. So I'm going to craft one up that I can make by drilling holes and bolting it together. That way, if I ever want to, redo it at some point and make a better version, I'm not out too much. But I didn't hit record on any of the video, so I just got a bunch of stills. So I'm going to talk over some pictures, and you can kind of see where I went to get to where we are. One place I can get super cheap steel is go to the conduit section in the electrical section of your hardware store. And that conduit is just a round steel tube that's galvanized. It's pretty good steel. It's not the greatest, but it's a lot cheaper than if you were to go and buy, square tube steel or whatever. At least in my area, it's cheaper to do it that way, so that might be an option if you're trying to do it on cheap. One thing I did is I bought some gauges and a new small tank, and these are things that you can source from like a salvage yard if you want. Just go out and just rip it out. But again, it's cold. I'm not going to go out to the salvage yard and start ripping out gauges out of a dashboard. That's just not going to happen right now. It's way too cold. It's like 8 degrees Fahrenheit today. So I'm not happening. I want to be warm. So I bought it instead. Sue me. All right. I got all the holes cut and I sanded down all the burrs. Got rid of the old paint and zinc that's on the back of this panel metal that I used from an old washing machine. And I gotta weld up those slits, and the control panel will be done and ready to install there. It's already snowing, so good luck with that. Alright, they're not the prettiest welds, but they're gonna hold. She's all cleaned up. I want to see how painting does, and I think it's 27 degrees maybe. It's damn cold. It was snowing out, so I brought the painted part inside. It's a little wet from snowing. Hopefully it dries in here. And not bad for being 20 degrees outside. That's 20 degrees Fahrenheit, by the way, which is below freezing. It's cold. Surprised I even got the paint to come out of the can. Zoom in on here. Oh, focus. See. There we go. So that is fisheye. That's from painting this out when it was snowing. Water gets trapped under the paint, evaporates, paint collapses in on itself. The solution is, don't paint in the snow. But also, if this happens to you, just know that you had moisture on the surface or unclean surface. You need to do better prep of the surface, and you won't end up like this. I mean, it is a neat texture if you're looking at the moon, but yeah, for this project, it'll be okay. And I got all the gauges, a power block, main terminals, and then down here we got a small fuel tank, and then there will be a battery next to the fuel pump right here. And then right in this space is where the radiator is going to go. I don't need a big one because I'm not going to be running the engine that long. And in fact, I probably don't even need the radiator at all, except for testing whether or not it's, completely circulating the water once I get the engine together. This is just the foam engine, but it sits there like that. And these studs go through a hole. This hole, the back side of the stud has a little plastic washer that's got, I don't know if you can see it too well, but there's a little raised bit that goes through the hole. So this hole's got to be big enough for this small diameter here, and then this backside sticks on the backside. Now let's try it. See if I can put that in there. So like that, you can see it kind of sticking out, and then the rest of it goes through. So the top side has a little plasticky bit that sits there, so it isolates the screw from the panel. It won't actually touch the panel, and that's how you put these in. Don't tighten it down too tight, because this is only plastic, so you will break it if you tighten it too tight, but tighten it down snug enough, and then that's how these go in. So they isolate themselves from the panel, and then you can pass through whatever power you want. Okay, so here we have fuel gauge. Doesn't really work. This fuel gauge here goes from 10 ohms to 180 ohms. The sending unit in the tank goes from 0 to 90 ohms, so they don't match. What I did is I put a few resistors in line with the line that comes from the tank up to here, so the needle goes in this area somewhere. It's not great, but it does work. RPM gauge here, switch for the turn on the fuel pump, and then the gauge. This is an auxiliary on for something else, probably the radiator fan I can control with this one. Here is the start button, just a quick momentary switch. We have the amp gauge here to check the alternator. This is the water temp. Sorry, it's a little dark. Water temp and the oil temp, battery voltage, and then the oil pressure. This is the main on switch, and these are the main, the big cables straight from the battery to the starter, alternator, starter solenoid, coil, and then these are just frame grounds to ground. One will go to the engine, base, and whatever else needs a ground from here. And then the fuel pump is wired up to here. I don't have it completely wired in because I'm just testing it right now with the smaller fan, but that's what these fans are, is to make sure that everything comes on when they're supposed to come on. And I'll demonstrate that in a little bit. Okay, just got some conduit from the hardware store. Drilled some holes, made an L bracket. Drilled some holes in this frame, bolted it to this. This is just a cheap, just an engine stand that you move around the engine on. But I added this bit to make the run stand. I put some extra little wheels on the front, so it didn't, so it doesn't tip, tip forward when the engine's not sitting on there. And then on the other side, I added another little brace, and it's quite good enough, solid for what I need it to do. So that's a cheap engine run stand, and now we'll go to the back side of it. Okay, it's hard to see, but the back side of the switch here takes power in through this relay, and then so I have switched power to this terminal block. And then there's also over on here on the positive side, we have a bus bar for the positive, for the high amperage stuff. This is actually just a bracket that I drilled holes in, stainless steel bracket to drill holes in. So it would definitely carry the load. Since I didn't need it to move, I don't actually need wires, just a conductor. This is a negative block here on this back side to spread out the negative load. And all of these gauges here are similar to this one. They have a light bulb that's to a common hot positive, and then this bracket pinches in to the back side of the faceplate. It's supposed to also ground it, but it doesn't quite because I've got this pretty thick paint on the back side. So what I did is I added an actual wire to ground them all together. So they're all grounded together. The light turns on, and then whichever function this is, like these will get actually installed on the engine once the engine actually gets here. So you got your temperature probes for oil and water. They'll get actually screwed into the block where they go. And then we've got, this is a mechanical speedometer that is actually going to hook up to the older transmission. It does not get hooked up to the coil, but this is a mechanical spin on this particular one. I do have a new, what I'm calling a newer type of RPM gauge that I can swap out if I'm doing a different motor. So this is a swap outable part. So yeah, that's about it. Sometimes you gotta take things back apart. One of these was in the wrong spot, and our reverse gear was too stiff. So that means I had the washers somewhere not right. I'm gonna go with this guy, flat one down here, and this guy with all the little dimples on the top, and see if that's the right round. You're looking at the book. This is a 4-speed Warner gear design. It doesn't look exactly like the one we have, but it's pretty close. This is a little bit different shape. Mounting holes for the levers should be back here, but I think this is just, one of a very similar model year. So if I look here, this guy looks pretty flat. They might have drawn some little dimples on this guy. So let's try that way around. I guess it can't be any worse than the way I had it.